Welcome to the fifth video in Physics C. This one deals with acceleration. And you should know the definition of acceleration from last year. It's the change in velocity per unit time, or mathematically, a equals delta v over delta t. It has a direction, just like velocity does. It's a vector. The acceleration and the velocity are not always in the same direction. We'll look at that on the next slide. But the way it's represented on the graph is by concavity. So let's say you have a position versus time graph. And it looks like this, and then it looks like this. And then here, this region of the graph is concave up, and this region of the graph on the right is concave down. Because the concave side of the graph, meaning the kind of curving inward, the one that's shaped like a cave, is above the graph here, and the concave part is below the graph here, so it's concave down. Concave up means positive acceleration. Concave down means negative acceleration. To see this, let's look at the graph of velocity versus time. So it starts out at a very small velocity here, the slope is small, and the velocity increases. And then when it gets here, the velocity is a maximum, because this is where the graph is steepest. And the slope then gradually decreases until it's back to its same slow speed as before. So here you can see the slope of this graph is positive over here, but then over in this half, the slope of the graph, the acceleration, is negative. And because this is calculus based, we can say that the acceleration is dv dt, or the second derivative of the position. Now the next question, you have the term not only acceleration, but you also occasionally use the term deceleration, speeding up, slowing down, to describe things that happen. We're going to try to avoid deceleration in this class, although your textbook uses it a few times. But what do we mean by slowing down or speeding up? What most people immediately think of when you talk about slowing down is, oh, acceleration must be negative. And for speeding up, oh, acceleration must be positive, but that's not always the case. What I'm going to show are 2 or 4 different graphs of velocity versus time. Label this graph 1, graph 2, graph 3, and graph 4. Now first off, for graphs 1 and 4, the acceleration is clearly positive because the slope is positive. And similarly for 2 and 3, the acceleration is negative because the slope is negative. In graph 1, also the velocity is positive, as is in graph 2. And in graphs 3 and 4, the velocity is clearly negative. Now the next question is, in which one of these would we describe the motion as slowing down? Well, clearly not in graph 1, because the speed, meaning the magnitude of the velocity, is increasing. And that we're going to need to ask, well, how can we look at the graph and say slowing down or speeding up? Well, if it's slowing down, the velocity is going to be getting closer to 0, not necessarily increasing or decreasing, but approaching the t-axis. Whereas if it's speeding up, v is getting farther from 0. So this one is speeding up. This one is also speeding up. And then these two are slowing down. If you look at the signs of A and V, what we can say about this is, well, the two that are speeding up, what they have in common is that the acceleration and the velocity are either both positive or both negative. So we can say that speeding up, which is a general term, means that A and V have the same direction. They're both positive or they're both negative. Slowing down, on the other hand, A and V have opposite directions. Either in the case of graph 2, A is negative and V is positive, or in the case of graph 4, A is positive and V is negative. So just be careful with your use of language there. There are no practice problems associated with this video, but you should also watch the next video, which deals with a mathematical application of this.